statistics questions, so when we've got sort of binomial contrasted with normal distributions. And I want to point out a few sort of key differences, things to look for to tell you what methods you should be using when you're confronted with different questions. So we'll also show you two resources I've got here for you. So in the Google Drive you'll find two stats booklets. One is called Stats Exam Questions, and that's just 28 pages of worth of questions. And then the other one's a bit more comprehensive, it's 73 pages, and that's from questions from the 2003 exam to the 2016 exam that are all relevant. So I've sort of harvested all the stats questions there. Now what we're going to do today is we're not going to answer these questions, rather I'm going to show you a revision technique where we're just going to read them. We're going to read them, we're going to sort of try and comprehend them, and then we're going to think, what is it I would do if I was going to solve this, and then move on. And that in itself can be a really good revision technique because firstly we're comprehending and we're saving a lot of time, all right? We're not investing heaps of time in writing out and putting these buttons in our calculator. We're saying, if I was to solve this problem, what are the strategies that I would employ? But the key difference we're trying to point out here is what are the key tells between a question that's binomial and a question that's normal. And there'll be a question later down that pops up that's actually both, all right? So I want to point that one out. So we'll just get you guys to have a bit of a read of this. Flynn, can you have a read of the first question here?
A common drug prescribed by doctors is known to produce a mild side effect. Records show that, of the people who take the drug, 1 in 8 experiences the side effect. For a given group of people who take the drug, let Y denote the number of people who experience the side effect. Given that Y follows a binomial distribution, calculate the probability that if 6 people take the drug, 3 or fewer will experience the side effect.
Excellent. So, I mean, the key tell here is a binomial distribution. Okay, so that should tell us we're looking at BPD, BCD calculations. Some other things to look out for, like I've got written here dichotomy. All right, so what's the dichotomy that they've created here? 1 in 8 experience side effects. So the dichotomy is side effects or no side effects. They're the two options. It creates a binomial, right? And they're about events occurring, okay? Whereas when we get into more normal, we're going to be seeing it's things that you measure, things that you weigh, or you pull your ruler out and you measure it, you see how long it is, and they occur over an interval. So there's lots of key differences. Let's keep going. So that's the first question there, that's going to be a binomial one. Okay, Noel, can you have a read here?
A local council decided to close Linden Road, a road that had been used by many thousands of residents. A random sample of 401 residents from the council area were asked whether they thought the road should stay open to traffic. As the residents surveyed, 212 said the road should stay open to traffic. K8, an approximate 95% confidence interval, the proportion of all residents in the council area who thought the road should stay open.
Very good. Okay, so calculate the 95% confidence interval. So we did confidence intervals in chapter 9, and we have confidence intervals for proportions, and we have confidence intervals for mean. This here says it's a proportion, okay? So they either want the road open or they don't. That's the dichotomy, right? That's the binomial. So here's the proportion that we're performing. It's confidence interval proportion. And we're only given 2 pieces of information. If you go into your calculator with that, what is it? It's X and N, all right? How many people said close the road, open the road? 212. Out of how many people are there in total? 401. That's the information you put in your calculator to generate that confidence interval. Okay, so that's question 8. And then here, if we scroll through, you're just going to be, here's an article, assess the truth of the article. Moving on. All right, this looks like a good one there, Tom.
In 1861, Dr. C.R.A. Wunderlich studied the body temperatures of many thousands of healthy people. The body temperatures were measured under standard conditions. Dr. Wunderlich concluded that for the population of healthy people, body temperature was normally distributed with a mean of 37 degrees and a standard deviation of 0.5 degrees. Using Dr. Wunderlich conclusions, find the proportion of the population of healthy people who had body temperature of above 37 degrees and above 38.
Excellent. Okay, so there's 2 things I want to point out here. Firstly, it's going to be normal, and there's a couple of tells. Okay, it says normal, provides us with a mean, provides us with a standard deviation. You might stumble over the proportion. So I'm not going to say proportion means, when you see that word, it means exclusively binomial. For a confidence interval, yes. For a confidence interval, yes. But here, it's asking us to calculate the probability, right? We have a mean of 37, and it says, what's the probability of it being larger than 37? Now just a couple of words we often ask, right? Probability, proportion, and then percentage, okay? So, if it says what percentage of people have a temperature above 37, you need to answer as a percentage. If it says proportion, you need to answer between 0 and 1. Okay, it's a proportion, you need to answer between 0 and 1, and the same with probability. Okay, so if it says either of those, the proportion occurs between 0 and 1. Only if it says percentage should we answer in percentage, although in the past they haven't been, it's not something that they've sort of picked on, right? So they're sort of accepting either, but that's the technically correct way to understand it. Okay, so that's question 11, that's a normal question. And then we calculate a confidence interval for the mean below, so we're using normal techniques and so forth. All right, here, like just looking at that, okay, where we've got histograms, and here it's a continuous variable. I know it's continuous because there's no gaps in between, and they're not taking whole integer values. So straight away I'm thinking that's a normal distribution. Have a look at the question. If you read through, normally distributed, we're given a mean, we're given a standard deviation. Okay, so we know it's normal. All right, we'll move on. The other thing to say here is we know from central limit theorem, as n increases, normality increases. So one of them's W25 and one of them's W. So the one that's more normal is going to be W25. All right, we know that from central limit theorem. We've seen that question before. Okay, this is a good question. All right, who are we up to, Ruben?
A manufacturer produces packets of potato chips. The label on each packet states that it contains 125 grams of chips. The machine fills the packets. The weight of chips delivered by the machine varies from packet to packet. Let W denote the weight of chips in the packet. The distribution of W can be modelled by a normal distribution with a mean of 125.8 and a standard deviation of 0.37 grams. Determine the proportionality of packets that will contain less than 125 grams of chips.
Very good. So we have a mean of 125.8, right? And it says, what's the probability of being less than 125, okay? So let's say we calculated that, probability of being less than 125, the proportion, and we got 0. What's it going to be, like 4-ish, 16 deviation, I'm not sure. Let's say, it'll be less, but yeah, let's just say 0.4. Yeah, let's move on to the next part. And Alex?
A random sample of 5 packets is selected. Let Y denote the number of packets in the random sample that contain less than 125 grams of chips. Y is a binomial variable. What is the probability that 2 packets will contain less than 125 grams of chips?
Okay, so this is where they're combining. And they do tell you, they say it is binomial, all right? And what's the dichotomy here? We've got, it's either less than 125 or it's not. Okay, so there's the dichotomy. And we're doing a sample of 5. We've got 5 packets, and they've said, what's the probability that 2 packets, so this is an exact outcome. What's the probability that the binomial variable, okay, so we have x was the normal variable, right, and so that's why they're using a new letter. What's the probability that the binomial variable is equal to 2? That exact event occurs. So that's going to be your DPE calculation. 2 successes out of 5 trials. And what's the probability of it weighing less than 125? That's this number we calculated in part A. So you can see how they combine those two together. But there's a couple of key tells there about what we should be using and where. All right, maybe we'll look at one more. So like I'm just going to scroll through. Look, we've got mean, standard deviation. So that's telling us normal distribution. Let's move on, see if there's one that's a little bit ambiguous. Okay, multiple choice here, right? So we've got each question in a certain multiple choice test has 3 alternatives. Only one of the alternative responses is correct. Okay, dichotomy. Answer is either right or wrong. Suppose that a student randomly chooses a response to one question. What's the probability that they're going to choose it correctly? Well, 1 out of 3, all right? So there's 3 possibilities. Only one of them is true, so the probability of it being true if they select it randomly, 1 out of 3. Okay, then we've got 10 questions in a multiple choice test. What's the probability that they would choose exactly 6 correct? All right, so exact outcome, BPD, It's discrete because they're not things that you measure, rather they're questions you get right. You don't get 5.456 questions right. You either get 5 questions right, or 6 questions right, or 7. They're discrete values. It's the probability of an event occurring, okay? What's the event? The event is getting 6 questions correct. All right? So anyway, this can be a good strategy, right? And I've only done it to the opening part of the question, okay? You know, so hopefully, like you can see what, pretty clearly where the question's going, and then they generally flow on. Although you did see as well, there is sometimes that they're asking a bit of both, but there are some key tells, all right? So I encourage you to do that as a revision technique. Like I've got an incredible amount of resources, and it's going to be really hard to work your way through all of them. But one thing you can do is just exposure to it, is to read through it, familiarise yourself, and then you can tackle it. You know, it's not like you have to tackle it by writing it out. Tackle it, what would I do if I was going to try and solve this problem? So, yeah, we've got those 2 documents there. So they're both on the Google Drive. So this is the comprehensive one, 73 pages. You can have a read through of that one. I probably won't print that for anyone unless you really want it. But I'm very happy to print a couple of these if anyone wants to go through them. They're specifically stats questions. There's both binomial and normal, and they are mixed up. So they're not all one way or the other. Cool, I'll stop there. That's where we're going to direct our efforts today. So in your textbook,